Hi, welcome to Essential IT and Security Skills. I'm Charles Redmond, Master Trader, here to guide you through the essentials that you are going to need to land the job that you are looking for. In this series, we're going to talk about essential PC skills. I'm going to walk you through everything from software to hardware. Most people know me as a cybersecurity expert. Well, I couldn't have gotten there without learning the basics first. That's what this series is going to do. And then we'll move on in some later series with some more advanced concepts and techniques. But remember, it all starts with the basics. It starts right here, the essential PC skills. First, we'll talk about network technologies. This is a typical physical topology of a typical Windows network. So understanding topology is the physical and logical design for a network to connect all of the computers together. The most common network topologies are called bus, ring, star, and mesh. In a bus topology, all computers connect to the network via a main line that's called the bus cable. In a ring topology, all computers on the network attach to a central ring of a cable. A star topology has all the computers on the network connecting to a central point, either a hub or sometimes most often called a switch. So with these topologies, we have for instance, mesh topology that connects each computer to each other via a dedicated line. There's also hybrids of each of these topologies. Those really aren't important to understand for the A+ certification, but in the real world, you're going to need to know how these hybrid topologies work. So first, we'll just talk about the network topology. It's the practical application of a topology and other critical standards to provide a method to get data from one computer to another on the network. The network topology defines many aspects of that network, from the topology to the frame type and cabling, as well as the connectors being used. Everything necessary to get data from one computer to another is defined by the network topology. In trying to understand topologies, you must first break it down to the basics, the frames and the devices that we use to get the data on the physical line. So the data from one PC to another is broken down into discrete chunks of data called frames. All NICs have a built-in identifier. A NIC is a network interface card. That card has what's called a MAC address. That address is unique to that card and unique to that computer. That's the only way networking works. The MAC address is 48 bits long. So each of these frames contain the MAC address of the network card to which the data is being sent, as well as the MAC address of the network card that sent the actual data. The data itself, well, it's going to vary in size depending on the type of frame that you use, which again will be dictated by the network topology itself. Also included in the frame is a data check. We call that the Cyclic redundancy check, or the CRC. Each frame must match the type of cabling, connectors, and devices on the network that carries them. So this is where Ethernet comes in. Originally, the digital equipment Intel and Xerox standard, they invented the first network in the mid-1970s and created what eventually became the Ethernet standard. Ethernet has gotten a lot faster and used in many different cabling types, but all flavors of the same frame. All three types of Ethernet use a star bus topology and usually connect via a cable called an Unshielded Twisted-Pair, or UTP. So understanding that modern Ethernet networks are all using a star topology, these topologies also combine characteristics of both the star and the bus. PCs connect via network ports on a switch or a hub, and that hub makes all computers share a given bandwidth. The connection between the computer and the switch is called a segment. These segments are limited to about 100 meters in length. The star bus network doesn't go down if the single cable breaks like it did with a simple bus network or a simple ring topology. So let's discuss the cabling a little bit, the unshielded twisted pair. This is the specified cabling for 10, 100, and 1000 base T networks, and is the predominant cabling used today. Different types of twisted pair cabling are available for the needs of different networks. Twisted pair is AWG 26 gauge wire twisted together into color-coded pairs. This makes it easier to put the connectors on so you know which pair is supposed to do what. There are actually particular standards for that, and again, we'll talk more about that later. Unshielded twisted pair, or UTP cabling, is identified in cat levels. Those cat levels define the maximum speed at which data can be transferred, also known as bandwidth. The major category levels are Cat 1, 3, 5, 5E, 6, and 6A. The A+ certification expects you to know and understand the different cat levels of UTP and STP cabling, as well as their standard uses and maximum bandwidth capacity. So as I indicated, the twisted wire that's in unshielded and shielded twisted pair cable is color-coded. That's so you can identify the proper standard for your organization. There are two that the A+ certification expects you to know and understand. It's the TIA 568A and the TIA 568B. So shielded twisted pair cable looks a whole lot like unshielded twisted pair, except the twisted wires are surrounded by a shielding to protect them from EMI, electromagnetic interference. It's fairly rare to see shielded twisted pair because first, it's extremely expensive, and really the only time that you need to run it is when you're going to be in an area that has excessive electronic noise, for instance, near an airport. So how do we implement these different types of base T networks? The 10 base T and 100 base T standards require two pairs of wire, a pair for sending and a pair for receiving. The 10 base T are typically using Cat 5 cable, where the 100 base T requires at least Cat 5 to be run. 1000 base T needs all four pair of wires in a Cat 5e or Cat 6 cable. So regardless whether you're using Cat 5, 5e, or Cat 6, or even Cat 6a, you're going to use the same connector. You'll use an RJ45. With a Cat 3 cable, usually used for telephone lines, you'll use an RJ11. Again, the A+ certification expects you to know and understand the two different wiring standards. Here's a chart to help you out. There you have it. It's pretty simple. Remember, everything starts with the basics. Once you have these understood, everything gets a whole lot easier. If you have any questions or even just a comment, feel free to leave them below, and I do read each and every one of them. I'll see you next time.